Yeah, so we're back. When we left off, we were talking about the stairway, and what I think we want to do now is to pop back into Fusion and look at some of the stairway details. I've turned off some of the portions of the building. You can kind of see where how the stairway kind of fits in here. If we and we'll look at some of the stair details. This is the stairway assembly, kind of in an isolated perspective of it. You have a finish. I guess it's called a finish stringer, which is this kind of orange element, and the you got your treads and risers. It sits on a plate of wood. If we look at the details, this is an individual stringer. It's cut out. This is cut out of rim board. And when you're cutting these, you want to be really careful that you make very good perpendicular cuts here. You don't want to have your least skilled carpenters doing this, and you want to lay it out carefully. You want to cut it carefully, and you want to verify it. We had a project where we did, and someone cut about 20 of these things, and they were completely screwed up. So we had to toss them, and it was an enormous waste of material and labor. So these are critical elements. You want to cut these carefully. So if we go back to the duplex assembly building, and you can see that I've turned off the visibility of some of these stair stringers. This element here is called the 2x4 bearing wall. It's one of the first things that we built, or that is part of this model, that is not built out of 2x6 lumber. It's made out of 2x4. It has sheetrock on each side. I was a little surprised at that, since I figured that it would have to, it supports. It's called a bearing wall because it bears a load. It bears the load of these floor joists. The rim board is along the top. The rim board sits on top of the 2x4s. If we look at the bearing wall details, this is a picture of it. This is the design of it. We can turn off some of the sheets and look at it. And it is not terribly complicated construction. It's simply a normal piece of carpentry. The 2x4s are in 24-inch centers. It's got a door header and a door enclosure. We may actually, I may have gotten this detail wrong. It's possible that we'll use some sort of door package here that eliminates the need for this door header. But it's pretty simple. Okay, we're back in the slides. We talked about the stairway details and the bearing wall. Okay, the porch. The porch is maybe the second most complicated carpentry element of the whole building. Porch roof sits above the front door. It's held up by the cantilever beam, which is made out of rim board. And you have some details about the porch rafters and a beam which helps hold up the porch wall. So we'll go and look at that. So this is the area of the porch. As I mentioned, you've got your cantilever beam, which is this red element here. You've got two pieces of rim board and your porch roof. Let's try to orbit around a little bit and look at it from a little different angle. Okay, here's our porch roof. If we go here, we can turn off the visibility of the porch roof so we can see some of the structure that is holding up here. You've got a beam here which goes from the cantilever beam over to the rim board. It's held in place on the rim board by a hanger, and you've got a piece of 2x4 here which is beveled so that it matches the angle of the porch roof. And you've got another angled 2x4 element here at the front. So that's and the cantilever beam is the one which holds up the whole assembly, and it's and so the dimensions of these roof rafters are sort of complicated. So I'm gonna try and open up a drawing for that. These are your porch rafters. This is what they look like. There is there's an element that goes in between here. This is a drawing that shows you the details of how to make a porch rafter. The angle here is 67 degrees. You wanna make a cut here which will accommodate your 2x4 elements. This is one of your more complicated elements of the whole building, and you wanna probably have your site carpenters build this. You don't want to assign your local Boy Scout troop to making your porch, because it's reasonably complicated, and you need to look at your architect plans to really grasp this. Platform framing is our next topic. So the top of the subfloor forms a planar surface. Second floor walls sit on top of that. So before we put our second floor walls on, we want to check that the subfloor is level. We also want to check the diagonal measurements of our building before we put those walls on. So we've achieved a 1/8 inch difference between diagonal measurements in past buildings. Now that's mighty good. If you can get 1/8, you're doing great. So when you get to this stage of construction, it's really good to have your second floor walls ready. Otherwise, you have to add some safety railings. So let's take a look in the model. I've turned off all the second floor stuff, and this is what your building will look like once you get your subfloor on. Once you get everything ready for the second floor. And what you would like to do when you reach this point of construction is you would like to have your second floor walls ready to go. You'd like to have them framed up, so all you have to do is use like the giant forklift and lift them into place. Otherwise, if your walls are not ready, what you have to do is build some safety railings around this edge, so that if someone was standing on this surface made of the subfloor, they wouldn't have a tendency to fall off. But if your walls are ready, you can avoid that step of the railings. Okay. So the top of the cap plates for the second floor also forms a plane. So the roof trusses sit on top of the cap plates. So you've got a number of planar surfaces in this whole construction process. You've got your foundation, you've got the subfloor between the first floor and the second floor, and you've got the top of your cap plates for the trusses. Now each of these three planes should be very, very flat and very level and very plumb, and if they're not, you've got to figure out what to do about it. So floor joists are engineered lumber. They're a key structural element for the building. They span between the party wall and the side wall. They're 24 inches on center, and they align with the studs. So there's 3 separate lengths of floor joists in the building, and I call them the A, B, and C joists. And we'll take a look in the model and see. So this view of the model, I've turned off the subfloor so that we can see each of the joists. The longest joists are the A joists, and there's 4 of them here that happen. The B joists are the shortest joists, which span between the stairway opening and the rim board. And then you've got another A joist here. Actually, you've got a couple of them side by side, and then you've got a C joist, which are intermediate in length between the A and the B, and they have to be a little bit shorter to accommodate this triple thickness of rim board. So that's where your joists sit. If we turned off the visibility of the OSB for this wall, what you would hope to see is that these floor joists are directly aligned on top of the studs. And I've actually gone into the model and turned off visibility of the OSB. And what you hope to see, and what we do see, is that in fact the joists and the studs are perfectly aligned. And so, because everything is on 24-inch centers, it all works perfectly. So, what you want to do when you're actually building the building is you want to compare the actual distance between the rim boards and the plans before you make any cuts to the floor joists. Now, I don't know, what we're building, what we're cutting is something that's just a little bit under 20 feet long. And I think a standard floor joist that comes off the truck might be 22 or 24 feet. So you gotta, pardon me, you have to cut them, but you wanna be careful when you're cutting them. And so you want to cut your longest ones first, and you want to measure it and cut one copy of the longest joist and test fit it before you cut any more. And the worst thing you could do is look at your plans and say, oh, well, I should cut these. You cut a whole bunch of them, and then you find out that they're too short, and you can't stretch them and you can't use them. So we have done this before, and it was embarrassing. It was expensive. So if you cut a joist that's a little bit too short, let's say you cut one of your A joists, it's a little bit too short, you might be able to use that for a shorter B joist, so you wouldn't have to waste it. But you want to verify in the field. You want to cut your joists to the actual dimensions between the pieces of rim board. Now, this is a case where you don't want to rely on the plans. You want to get out your long steel tape measure and measure it before you start cutting. So, like I said, joists are 24 inches on center. They get nailed to the rim board and the top plate. You probably have to use some hangers. Your structural plans will tell you. The subfloor sits on top of the joists in a checkered board pattern. And so let's take a quick. So here we are looking at the model. I've turned on the visibility of the subfloor, and if we turn on this sketch, we can see the joint pattern of pieces of subfloor. And you don't want four corners to meet. You only, it's pretty obvious. Once you get started with this, you can see that we've got half sheets which are adjacent to full sheets, and a full sheet, full sheet, full sheet, half sheet. We have some pieces here that are probably neither exactly a full sheet nor a half sheet. You got an L-shaped piece here near the porch. I think I remember that this particular sheet here near the stairway is neither a full sheet nor a half sheet. So before you put your subfloor down, you want to put subfloor adhesive on top of the joists, and then put your pieces of subfloor on top of the wet adhesive. It'll avoid squeak. In some cases, we've used screws. In the structural drawings talk about nailing of subfloor, so we'll probably be nailing it. Gun nailing is really fast for subfloor. It's easier and faster than using screws, but screws avoid squeak, so we'll see. Okay, trusses. I don't have any detail in my model about roof trusses. Roof trusses are manufactured out of 2x4 material. They arrive on a truck. They're simple. We don't have to design them. They lift them into position with a big crane. And it's a really fun part of the work because it goes fast, and you feel like you're really putting the building together when you're putting those trusses on, and it makes your building very complete. It looks much more complete with trusses in place. Okay, so there's one specific area where we deviate from the architect drawings, and this contains use of standard stud lengths. We're using standard studs of 104 1/4 and 92 1/4. this gives us wall heights which are slightly different from the 10-foot and 8-foot wall heights specified by the architect. And this impacts the stairs. Now your architect specifies risers which work for a 10-foot stair height or a 10-foot wall height. But if we're making something that is different, we have to have different stairway dimensions. So we have to be very careful, because we have subcontractors who are building, half of our buildings, and it's very likely that they will follow the plans exactly. And so, they're likely to make 10-foot and 8-foot walls and cut their studs down. I don't know. I'm not sure exactly what they're doing, but we have to be careful, because at our previous project, we had some major problems. We had walls that didn't line up because one set of contractors were, one set of builders were using standard studs, and the other set were following the plans exactly. And so this is where we have to be careful. Now, my drawings and my plans rely on the concept of using standard studs. So we're going to have, if you follow my drawings, which I hope you will, and this is what our project leadership wants, is we're going to get wall heights which are slightly different from what the architect plans specify. So there's some things that are not in the drawings or the model. So if we look at structural blocking, if we look at detail 12 on page S7, there's no structural blocking in my plans. So I should have put it in there, I just didn't do it. But it's something we can do. It's not going to screw us up if we put it in later, but it is important. So let's quickly look at that plan. This is page S7 of the structural plans. If we zoom in on it to detail 12 here, which is in the upper left corner, you will see that it calls for 4x4 blocking, or double 2x4s, in the areas near between the studs adjacent to the windows, and you may have a need for additional blocking in other parts of the building. But that is an important detail. So don't forget it. If you follow my plans exactly, you need to add some blocking. There are also a lot of important details about hold downs and Simpson hardware that you really need to consult the architect and structural plans for that. And I haven't put any roof trusses in my model. When I got the copy of the plans, the roof trusses hadn't been designed yet. In some cases, we have shear walls that have OSB on the interior portion of the walls. Now, my drawings don't show that, but you better make sure that you get that in there, because it's important for the strength of the shear walls. And another aspect is that my drawings show long elements, such as top plates, as being one continuous long board. Now obviously that's incorrect. You're going to have to make your long elements, such as your top plates and your cap plates, out of a number of smaller boards. And the structural plans specify that you have to have at least 4 feet of overlap. So that's just simply something that my drawings don't show. But if you go to the truck and try to find a 20-foot long piece of 2x6 for your cap plate, you're going to find that you don't find it. So you're going to have to use some shorter pieces, such as get yourself a 10-foot 2x6 and nail it together. So here are some numbers just to try to get into your brain. After you've done all this stuff for some period of time, you have these numbers memorized, but it's just important. I'm sure you guys know, now, I'm sure you all know that a 2x4 is not 2 inches by 4 inches. Memorize your dimensions of standard studs, 92, I think that should actually be 92 and a quarter, not 190, not 92 and a half. 48 by 96 is what you get with 4 by 8. 48 by 108 is what you get with 4 by 9 OSB. OSB is 15 32 inch thick. Standard edge and field nailing is 6 and 12. A piece of rim board is 1 3/4 inches thick. It's 11 7/8 inches wide. And a standard stud bay is 22.5 inches wide. If you are nailing 24 inches on center and you're using single studs. If you got double studs, your stud bays will be different, and also your stud bays are going to be slightly different on the ends of your walls, so that your pieces of OSB are not going to meet in the edge of your end stud or in the middle of your end stud. They should be on the edge of the end stud, and so a stud bay on the end of a wall is going to be 3/4 of an inch narrower than 22.5. So, a recap, we talked about the 3D model. We looked at some of the drawings generated from the model. We talked about the foundation, the walls, the rim board, the joists, the stairs, the porch, and the roof trusses. We talked about how the various elements of the building are going to fit together and align with each other. And now, of course, there's an awful lot more stuff that you need to do in order to make a building. And you got your insulation, your plumbing, your electrical, your interior walls, and your sheetrock, the ceilings, the flooring, the windows, the baseboard, the trim, the painting, the roofing, the landscaping, the fences, the drainage, the lightage, and the parkage. It's a lot of stuff, but hopefully it will be simple stuff if we get our framing correct. It'll be straightforward work. It's obviously a lot of work, but if you get the foundation and the framing and the sheathing correct, the rest of it is straightforward. So we're going to build this building. I'm really excited about it. Like I said, if we get the stuff in this presentation correct, everything else should be simple and straightforward work. So I'm really looking forward to making this building, and I'm looking forward to working with all of you. Hopefully the rain will stop and we'll be out in the sun, the mud will dry up, and we can get going. So look forward to seeing you all, and I hope you've enjoyed this presentation of my slides and my model.